And next one is bandwidth. This is a very important derivation. So bandwidth. So we know that I naught or I maximum is equal to V by Z minimum. That should be equal to V by R, and the power is equal to I naught square into R, that is V square by R square into R, that should be equal to V square by R. If I am getting the half of the power, so this is the current versus frequency. The current is maximum at resonant frequency, and this is a curve, current versus frequency, and this value is called the I maximum, where I maximum is equal to V by R. At half of the frequency, P0 by 2 is equal to V square divided by 2R, or I naught square by 2. So I naught by, I can write it as root 2 whole square into R. That means I max by root 2 whole square into R. So I can find it as I max by root 2. I max divided by root 2. It will touches the current curve at 2 points. One is lower cutoff frequency and higher cutoff frequency. Another one is higher cutoff frequency. Lower cutoff frequency is represented with F1. Higher cutoff frequency is represented with F2. And this is a half power frequencies F1 and F2. The half power frequencies are F1 and F2. So as I am getting, bandwidth is equal to F2 minus F1, that is in terms of hertz. I is equal to V by Z. We know that I is equal to V by Z. V by under root of R square plus omega L minus omega C whole square. That is the current value should be equal to V by Z. Since I is equal to, I want to derive the frequencies at half power frequencies. I is equal to I naught by root 2, or I naught is equal to V by R. Since I naught is equal to V divided by R, and both the currents are same, these impedance values or current values are at half power frequencies. So V by root 2 R is equal to V by under root of R square plus omega L minus 1 by omega C whole square, and here V will be cancelled and square on both sides. 2R square is equal to R square plus omega L minus 1 by omega C whole square. Omega L minus 1 by omega C whole square is equal to R square. Omega L minus 1 by omega C is equal to plus R minus R. Now tell me, at what frequencies it will be positive, at lower frequency or higher frequency? At F2, is it positive or negative? See, at lower cutoff frequencies, if you observe, at lower cutoff frequencies, XC is greater than XL. That means this term is negative. So omega 1 L minus 1 omega 1 C is equal to minus R. This is the first equation. At F2, XL is greater than XC, then this term is positive. Omega 2 L minus 1 by omega 2 C is equal to plus R. And by adding these two, add 1 and 2, then omega 1 L plus omega 2 L here minus omega 1 C minus 1 by omega 2 C is equal to 0. Take L is common, omega 1 plus omega 2 minus 1 by C is common, 1 by omega 1 plus 1 by omega 2 is equal to 0. And L into omega 1 plus omega 2 minus, take LCM, omega 1 plus omega 2 divided by omega 1 omega 2 c is equal to 0, and omega 1 plus omega 2, take this is common, L minus 1 by omega 1 omega 2 c is equal to 0, and this term is not equal to 0, and obviously the second term made equal to 0. L minus 1 by omega 1 omega 2 c is equal to 0, and from this I am getting omega 1 omega 2 is equal to 1 by LC, and what is 1 by LC? Omega naught square is equal to 1 by LC, since omega naught is equal to 1 by root LC. Omega naught is equal to 1 by root LC, omega naught square is equal to 1 by LC. So I can read it as omega naught square is equal to omega 1 omega 2, then omega naught is equal to root omega 1 omega 2. So this is a very important derivation. Once again I am explaining, at a half power frequencies f1 and f2 we are getting. At half power frequencies, what is the current? V by z, V by under root of r square plus omega l minus omega s whole square, and the current value I naught by root 2, where I naught is the maximum value, that is V by root 2 r. Equate this, and one term we are getting a positive and another term we are getting as a negative, and at lower frequencies the value is negative, at higher frequencies the value is positive. So that's why omega 1 L minus 1 by omega c is equal to minus r, omega 2 L minus 1 by 1 is equal to positive r, then add. So now subtract 1 and 2. 1 and 2. So then what I am getting here, this is the value. What is the value here? Subtraction. What is the subtraction of 1 and 2? Omega 1 L minus 1 by omega 1 c minus omega 2 L plus 1 by omega 2 c is equal to minus r, it should be equal to minus 2r, and here what we are, L is taken as common, omega 1 minus omega 2 plus 1 by c, 1 by omega 2 minus 1 by omega 1 is equal to minus 2r. Omega 2 minus omega 1 into L plus omega 2 minus omega 1 divided by omega 1 omega 2 c is equal to plus 2r. So take a minus is common here, then you will get the omega 2 minus omega 1 minus, and here I am getting omega 1 minus omega 2 by omega 1 omega 2. Again take a minus common and cancelled out. Then take omega 2 minus omega 1 L plus 1 by omega 1 omega 2 c is equal to plus 2r. So this I can substitute here, omega 2 minus omega 1 into L plus 1 by omega 1 omega 2 c is equal to 2r. What is omega 1 omega 2? That should be equal to 1 by LC. So omega 2 minus omega 1 into L plus 1 by LC into C, and CC will be cancelled. From this, omega 2 minus omega 1 L plus L is equal to 2r, and the omega 2 minus omega 1 is equal to r by L. So what is omega 2 minus omega 1? Is a bandwidth. Omega 2 minus omega 1 is equal to r by L. If it is in terms of frequencies, f2 minus f1 is equal to f2 minus f1 is equal to r by 2 pi L. And in a JNTH examination I can expect this question, and from the resonance is very important derivation.